Hello everyone, welcome to my YouTube channel. Today we are going to do end-to-end project from the starting of a scratch where from I get the data sets to doing the machine learning and finally creating an basic application in Flask and deploying in uh, committing in pushing the code to the GitHub. So therefore how to deploy into the Heroku app. All the things can be covered in this session. So let's move on. So first of all, the basic requirement is an data set which is required. So first of all, we can go to the kaggle.com. So it's an best website to get all the data sets of different types of categorical or regression classification one issues. So directly if you click on the classification, all the classification issued data sets are there. So let's go with the mobile price classification. So you can see over here and under the first column of about the data set, it will explain all the context of this data set, what is having the things. The person Bob has his own mobile company. He wants to find which all the things are required to solve this problem. So you can see over here the test and the train documents are there, but we can take any one among this one. So over here what all the things are available over here. See, the 10 of 21 columns means the test case having 21 columns, but it is showing only the 10. So if you want to see all the columns, you can click over here and select all and click on the apply. So you can see all the things which are available in the data set: ID, battery powered, Bluetooth, clock speed, dual SIM, front camera, 4G, the network, internal memory, okay, depth in centimeters, weight, number of cores, primary camera megapixel, etc, resolution, height, width, all the things which are required in the mobile are available over here. But the main thing which we required is to find the price. The price is available. Okay, fine. Price is not available. We can check it in train. Okay. All the things are same, but see, if you want to, yeah, a price range is available. So it's the last thing. So over this is in classification, right? So it was categorized into three things. One is in four things: low cost, it is 0; medium cost is 1; the second one is high cost, very high cost. It's like base phone, medium phone, top end, exclusive phone, like that it is categorized. But let's see, we can take the test. We can go either of this as the test having the lot of things, or else we can take both the things. If you want, if you we can take both the things as I want to explain about the splitting of the test and train, how we can split and work on it. So I'm taking only one. Let's see, it is okay, it is downloaded complete. Two sets, can directly copy anyone. I'm copying this and I'm creating a folder called mobile price. prediction. Basically I follow this convention, but you can follow it in any sort of thing. Make sure that after space the python or any sort of library name is not available, or basically you can use hyphens after every word, so that will make sense. It is used to read easily, and paste over here. And I want to rename it as data to make it easy to understand. Means all my files are renamed to data itself. And as I am using a Chromebook, it is not capable enough to do the machine learning sort of big task in one go. So over here there is an website called Amazon. In that I use the SageMaker web maker studio. So you can get an free account. It is not chargeable. Over here it is giving us CPU of 12 hours and the GPU of 8 hours continuously working on. You can reset at any time by just on clicking on CPU. Click on start runtime so that it can open up. So meanwhile we can go to the website and check all the information, like how many columns are there, how many rows are available over here. Maybe okay, we can find it in the Jupyter notebook itself. Okay. Oh, it is the clock is started, and over here it is showing the open project. If you click on the open project, it is directly opening an Jupyter notebook where you can work on the files. It will take some time. Yes, it is opening. So first of all, okay, I'll create a folder called mobile price prediction. So in which I'll just import the data file which I had copied previously. So the data.csv has been created, and I create a notebook file. So, and I will rename it as learn.ipynb. So first of all, if you want to load a data set, or if you want to use the Python for the data science or machine learning project, we need to have imported libraries in the Python itself to get basic libraries to be imported. We can use the libraries called Python, pandas, numpy, matplotlib, and cbon. So we can do import pandas as pd, import numpy as lb, import plotlib dot plot as plt, import cbon as these are the things, these are the basic libraries which are required to execute the basic program So just run this one to get all the basic import libraries in our environment. Once it has been done, I'll import the data.csv. df is equals to pd, the pandas which we have created, pd dot read csv. Read csv is a function by which we can import the data as data.csv. It is imported. First of all, we need to check whether it is imported or not. To find out, we can use df. We can print df, but if we just required to evaluate, right? So first five rows is enough to identify that the data is imported. So for that we can use head command, df dot head. Click this one, then it is showing all the things, but it is showing 5 into 21 means rows and the columns of 5, which I had previously said. The head and 21 columns are available over here, which we have seen in the Kaggle. The same things has been came over here. So first of all, to identify how many rows and columns are available, yes, obviously columns are available as 21. It is already mentioned, but still if we want to know, we can type df dot shape. If you click over here, it is showing that 200 rows and 21 columns are available in this data set. So if we want to know further how many information about this data set, we can type df dot info. Info command will give all the insight and what all the data types of this data set. We can see a battery type, battery power, it's all are 2000 value rows are available. Those are not null and having an integer type. And similarly you can see mdep is also 2000 rows and having a not null and with the float 64 values. So basically it will show what all the things are available over here. So if you want to get the categorical, the numerical variable identification, means like statistical values of this particular columns, like mean, the average, the first quadrant values, second quadrant values, minimum, maximum, you can use a df dot describe function. So it will give all the count, mean, standard deviation, minimum, maximum, at the time of 25%, how many values are there, 50% and 75%. So all the things we can find out. But if you can identify this, because of its length of 21 columns, some of columns have been choked. To get all the columns, we can shift this table, or transpose this table by using a transpose command. I'm using the same command, df.describe, as it is giving an categorical or statistical variables in the columns, dot transpose. So we can identify that the rows have been converted to columns and columns have been converted to rows. This count, mean, standard deviation, minimum 25%, 50, 75 and maximum has came into the column sections, and all the columns have came into the this is not an changing of the data set, but it is an visual representation. If you click again df.head, it will shows in the same thing which we have previously saw. So we can see the things which are available over here. And finally, yes, basically info will give all the insight of null values are available or not, but we can check it via a command called df.is null is an giving and boolean values of null values which are available in the data set. So if you want to count how many are available if you want to sum up all the values which are available in a particular column, we can use the sum function. And if you click by the column categorical, it is showing how many null values are available in the particular column. But over here the data set is clean, we can identify that the null values are not available in this data set. So we can move further and do some other insight understanding. Let's see what all the unique values are available in Wi-Fi. So we can get df.wi-fi dot unique command is an to find the things are available in the Wi-Fi section. It is the 1 and the 0. Similarly, we can find the price range because the price range we have already saw that four different types of information are available over here. And the price range, df.pricerange.unique. So it shows what all the things 0, 1, 2 and 3 are available over here. And let's say it is, I think this is the more number of items are available in this internal memory. We can see internal memory also. Internal memory dot unique, we can find these many things are there. Instead of looking for each and every column, we or else there is to find out all the columns in a row or in a list type of thing, we can get there is a command called df.columns where we can find all the columns are available in this data set. To find the unique values of the to find the unique values of all these columns, we can create column is equals to this type is an panda series, but if you want to convert it into list, we can use list and directly type this df.columns. It will convert and store into this call. Once it has been stored, we can use for loop for I in call print, let's say I'll give a gap, df of I dot unique. So let's see, yeah, for the battery power it is showing so many values. For the blue it is showing 0 and 1, clock speed so many values, and dual sim yes or no, like that it is showing. For all the things which are available in this dataset are shown over here. So fine, we can further move on to the data analysis. Data analyzing what all the things are available in the data sets, we can see. So first of all, we can so we need to identify the this data set result is unbalanced or imbalanced. To find out, df.i iloc is a command to select instead of typing. We can even write the price range which we are selecting, on which we want to do the analysis. Value dot values dot count means how many values of 1, how many values of 2, 3 and zeros are available in the particular column. It can be count by using values value dot counts. So all the datas having and 500 number of rows in a particular value, so it is unbalanced as it was there. So we can evenly identify by using divided by length of df. Then it will give the percentile values of 25 percentile, 25 percentile, 25 percentage of the values are allocated to 1, 25 of 2, 3 and 0, vice versa respectively. So if we want to identify the correlation between the values and the price range, we can we can use the function called correlation. But this to be plot to plot this thing, we can use the support from matplotlib and the seaborn to print out the values. For the printing the correlation values, we need to create a figure first. To create a figure, plt, which is a matplotlib function figure plot dot figure of fig size of let's say 10 by 10. We can see we have initialized the figure size, and by using SNS seaborn function heat map to get good visuality of the correlation of df dot correlation dot I want to see the annotation, means what all the how much correlation is available in the in particular row and column by using annotation function. Annote is equals to true. So finally I want to show the heat map. So plt dot show, and if you want to save this file, plt dot save fig, and the name is correlation dot jpg or png, whatever. If you want, you can do that and click enter. df, it is showing some okay. This should be not a dot, it should be a comma, because so if you click this seaborn will take some time. As you can see over here, it is a bit clumsy, so we can go and change, we can modify at any point of time and click on the values to be changed, and it is showing that the values are like so. But see, if you want to know more or understand, we can directly jump on the values which are available over here, but we can move on. We can't able to identify that the values are, the particular values are present or not, like that. Okay, we can see that this data is fine to work on this data. We can do one thing, splitting this data into 20/80 ratio, means the test data is of 80% data, and the remaining 20% is of train data, for the test data. If you precisely understood, 2000 to 1600 value, 1600 rows are going to the test data set, and for the train data set, it is around 400 data sets are going to be allocated. To split the values, we have sklearn. In the sklearn, we have a module feature called train test split. First we need to import that to splitting our data from sklearn dot model selection, import train test. If you are new and if you are confused with what I'm typing, don't worry, it is already available in the sklearn website with how to import and what to do with the splitting the data. We can do things. So and if you want to split the first, after importing the data, we can do the splitting process by taking 4 commands. By the splitting, we will get 4 output values, which are x x train, x test, y train, and y test. We can use the train test split to split the values. Before splitting this one, we need to segregate or split the data in terms of x and y. So I'm creating 2 empty values over here. So what all the things are needed in x are capital X is equals to df.iloc. Iloc is a command to fetch the data. So over here, this will take an input like rows and the columns. Rows means if you want to create end to end, means if you want to select all the value 2000 values, we need to keep the semicolon, so that from the beginning to end it will fetch all the information of rows and comma. We want to fetch all the things as except the last value, which is price range. Then I am keeping an colon -1, so it will take like this. And similarly, I want to keep the price range in small y, then df dot iloc. Iloc will take 2 commands, one is row and another is column. I want only one column, then I'm taking -1 as an column. So if I click control, if I run this one, it will execute successfully. I want to validate whether it was import, means it was created or not. So for that, print x dot shape and print y dot shape, so that I can understand that it was split. Yes, the 2000 values of 20 columns have been imported to this one. As it was having 21 columns, one column has been came into the, and the rows are 2000. So I can easily take x comma y, and these 2 values has been taken after split to give the values of test or train size. We can use any one of them, like let's say test size equals 0.2, and the randomness should be given. You can give any value, but most of the time if you want to give the complete randomness, then you can use 100 as an input value. Random state equals to 100. So this will make your model has been splitted. Fine. We can check it via the shape functions. As I was saying that it was splitted into extrain, I mean the 20% split is there, right? So extrain and filtering. You can check that 1600 has been came into the train data, and for the test it will be 400. Yes, 400 has been splitted. So now the data has been splitted successfully. To now we can further move on to the machine learning classification problem. So for the machine learning, we need to import the algorithms in the Python. By using the sklearn, we are going to import the particular libraries. The first library which we want to work on is linear model, which can be imported like from sklearn import linear model. Okay, we can click. So if you don't identify what all the things are required, you can directly Google search. I'm doing the I want to import the logistic regression library. Logistic regression. See, I'm just clicking on this, so it will give. You can use like this also, or else you can from import type of thing also you can use. You can read the form the description which are available. So from sklearn.linear model import logistic regression. Same as logistic regression, I want to do the random forest. This is this scikit-learn homepage, right? So you can directly click random forest. Classification or classifier. Better to do Google, so that it will go to the particular thing. It will also go to the correct site, but doing the Google make life easy. From sklearn import random forest, and finally we have st descriptor. sklearn. Or else we can remove the random forest. This is an okay. Let's remove this one. So for the regression one, we required logistic regression, logistic regressor. Then after Gaussian, sorry, KNN, import KNN. So you can directly click on the import. From sklearn import KNN. Then we have decision tree. Decision tree classifier in our nav bias. Okay, yeah, Gaussian NB, yes. So finally, if you want to import SVM or SVM model, we can do search for that also. SVM support vector machine. I think this one. Over here there are two things are available here, SVM and linear SVM. From sklearn import and linear SVC. This can be helpful. And finally we want to do the pre-processing. This is also from sklearn. We don't need the standard scaler, so I'm directly importing this thing is enough for me. From sklearn import pre-processing is enough. Finally, if we want to, as it is a classification program, then we need to do the matrices for the for identification of the confusion matrix and the accuracy of the data set which we have splitted. To import that one, we need to do matrix import matrix because metrics are a large number. In Keras also it is there, in the Python also it is there. So I'm importing the accuracy score from sklearn. It is the libraries of sklearn. So I'm copying this one. Accuracy score, if I import the accuracy score, it is limited to accuracy score, but I want to import all the libraries, or all the value functions are available in the metrics. So I'm importing all the metrics. Like, I'm removing this one. So now all the metrics values has been algorithm has been imported. So once it is done, so I'll how we can import the values, like we can use um, let's say LR equals to, it's a logistic regression. So logistic regression, so I'll create an variable object. So I want to create LR dot fit. What all the things I need to fix is, I want to give the training data in this X train, comma Y train. I want to predict this one, or we can create Y pred equals to LR dot predict function for by using X underscore test, which we have splitted, right? So I'm predicting all the x values and storing it in ypred. And once it has been stored, I want to do the validation, cross validation of confusion matrix and accuracy. For that, I'm printing as matrix, which we have imported over here from sklearn. What I'm using is confusion matrix. I want to compare the actual value versus predicted value. So actual value is y test of this x test, and the predicted value is y pred. So I'm comparing this between these two. If I click and even though I want to print the accuracy between the x and y prediction, so what I'm doing is I'm just copying this one, and instead of accuracy instead of confusion matrix, I'm using accuracy score. And yeah, it's good to go. And I run, then the confusion matrix has been created as this one, but accuracy score, oh okay, the capital is not available and it's small. The accuracy is 61.5%, means 61.5%. So instead of we have these many algorithms, 1 2 3 4 5 algorithms are available, but if we do like this, then it will take lot of time. And one more thing is, in the KNN decision tree and SVM, we need to do the iterations to find out the accurate value. So for that, what I can do is um, I'm creating an function as custom function where I kept all the steps which we have done in the above one. I imported the logistic regression in LR and fitted the model. Once I predicted, I printed the confusion matrix and accuracy score for the logistic regression. Log rig I gave. For the naive I gave naive. While coming to the KNN, we have two types of methods to calculate the KNN value of neighbor, counting the neighbor values. One is Euclidean and another is Manhattan. So to find out the Manhattan value, I created a range of 1 to 10 on and gave into the neighbor values to iterate this KNN one to get all the values has been okay. This KNN have we put it as KNC. Okay, so I have renamed, means I have modified, instead of giving all this the large value, I modified it as KNN or as DCT for the decision tree. So once I imported this one, I'll rerun for the Manhattan. For one neighbor it is showing 88%, 88%.5, like that it has been shown. The best value is for the Manhattan is 3 and 3, 4 and 5, because it is showing the larger values. I don't want to means there is no much difference between this values and this value, so I will stick to the 3. And coming to the Euclidean, instead of Manhattan, I'm just rerunning the same values by keeping in the loop. For the Euclidean, 92%, and yes, in the Euclidean for the third neighbor it is giving the 92% accuracy. So instead of going to the Manhattan, I am going to the Euclidean with the value of 3. So I am changing it to 3, and I am keeping it in Euclidean and running this. It has been came into this function. So similarly, support vector classification also, I need to find the C value for the support vector. So I am doing the running the loop, so I'll get more accuracy in the support value. So for this 3, I'm getting good 95% of accuracy, so I'm keeping this one. And for the decision tree, there are two methods of decision tree calculation. One is entropy and another is a Gini. So over here also we want to find out the Gini value, Gini mag depth and entropy depth value. I'm running a loop to find out the accuracies. So it is showing lower values, but at the 5 it is giving the 80%. And coming to the entropy, it is showing some fifth value as 81, so or 82 for the sixth value. So I'll take any one, because no matter, the both are showing worse values. So I'll go with the entropy with the value of 6. So I'll comment it out. I'll comment this one, and the max depth value is 6. Okay, so I'll run this. If you want to run, showing this confusion matrix with 80%, and KNN it is showing 92% with this confusion matrix. Finally SVM is showing 95%. So I just want to stick with SVM as it is showing the 90 highest among all the things. So what I can do is I'll just copy these things are the model or X predict, Y predict. Yeah, this one is fine for me. Fine. So now what I'm doing is I'm just taking this out to create or generate a model from this. I don't need this also. I'm just not predicting values, but one thing I required is a library to export this one. For exporting the model, we have two libraries. One is pickle and joblib. uh, as per the preference, you can use any one of them. I'm putting the joblib. Port joblib. So once it has been run, model.svc fit, I have fitted the model, and finally joblib dot save, or for the saving we use a dump. What we want to save is model, and what is the name of the model is still model. So yeah, model. When I run this one, the model has been created over here. Now what we can do is we can get all the values, let's say we have dot, so that I can see all the values. I'm using the transpose. Yeah, it is not choked. Yeah, what I want to see is I want to take the one value and the two value. So for this one and two value, what I can do is so I'm thinking to export. Oh my god. 0.2.001 no issues. It will convert it. It's integer and float values. It is okay. 0,7,0.6, 188, 756, 549, 7. Okay, last value is not required. Similarly, INP1 and INP2. What I will do is I'll write this one and take this one. One two six three 1716 2769 16 8 11 0 0 2. Oh, 2 is not required. So coming to the front, uh, 563 1 563 1.0.3, I guess. 0.5 1 to 1 1 to 1 is already we have to the values. Okay, input value have been stored in inp1 and inp2 for this one. To identify, we can import this model into the existing one. For this, I'm taking one variable called sol. In that, I'm loading the model as job lib dot load by using this function. What I'm going to use model, and getting a result is equals to solve dot predict one, or else what I can do is print p1 value is, no worries, this is fine. And same thing, and p2 value of 2 is p2. Okay, right now I think, okay, 2D array, it is only 1D array, so I'm changing it to 2D array so that it can be solved. So yeah, as you can see, the first value is inp value 1 is 1, and inp2 value is 2, which is 2. Then fine, the model is created successfully. Right now what I will do is I'll just take this model and download, so that I can use this model in my local